This is your computer. But a computer on its own isn't very much fun these days. No, we're all networked together. Every computer, phone, and refrigerator is on a network of some sort, and all of these networks are interconnected, like some sort of giant tangle of dump trucks and tubes. You and your computer over here, and you just typed in google.com, which is this computer over here. You get a nice little search box on your screen. It all looks so simple, but in less than a second, a lot of things just happened. A DNS query was made, a TCP connection was opened, a SYN-ACK handshake was negotiated. All of that, those are the processes that make up networking, and it's all very daunting. Let's make sense of it by simplifying things. Here's your computer again, but this time we're not on the internet. It's kind of like that scene in The Matrix, except I'm not going to show you a ton of guns. Okay, well, just one gun. Anyway, it's just you and one other computer. You're connected together through a network, and networking ultimately is about sending messages between computers. Let's start by sending the simplest message that we can. The most basic message in modern networking is the ping. Basically, we can ask one other computer on the network if it's alive and responding, and if it is... Okay, I made that up. The technical term for a ping is an ICMP echo request. Our request includes something called a payload, which can be any message that we want. The computer on the other end is obligated to reply with the same message. In reality, it looks a little bit like this. So, how do we ping another computer? Most computers come with a program dedicated to doing exactly that. Unsurprisingly, it's called ping. Fire up your console and we'll play with it a little bit. If you don't know how to use your console, watch my previous video first and come back. I'll wait. You need to specify a target to ping. We use numeric addresses to refer to specific computers on a network rather than names. This doesn't sound right at first, I know, but I'll get into the specifics later. You've probably seen these numbers before, 4 numbers separated by dots. They're called IP addresses. There's one IP address that's always accessible to you no matter what network you're on, 127.0.0.1. Let's try pinging it now. These lines you're seeing, that's the machine responding to our pings. The most interesting thing on each line at this point is this last entry where it says time. This tells you how long it took to send a message and receive the echo back. So what supercomputer is at this mysterious address that responds to your messages in a fraction of a millisecond? There are really only 2 candidates, and it's not the giant Wi-Fi router that powers the heart of the internet. It's your own computer. This address is sometimes called home, and it's not a real IP address as much as it is an alias. It's a way for the computer to refer to itself. Now that we have the syntax of the ping command down, let's try a real address. This one might not work for all of you, but let's try pinging this anyway. Notice how long the pings take. It's not sub-millisecond, but if the stars align, it'll be pretty close. This is the address of your Wi-Fi router. It's physically close to you, so pinging it is really fast. If this didn't work for you, it's possible that your Wi-Fi router has a different address, and I know some of you are thinking, wait, how is it that we all have the same router address? Am I pinging someone else's router when I type that? You aren't, but the details are a little complicated, and I'll cover that in another video. Let's keep going. Depending on where you are geographically, this next address might give you a wide range of response time. From where I am, I'm getting about 12 milliseconds. This might be as high as 75 for some of you. 12 is still considered pretty fast. Definitely fast enough that it looks instantaneous to a human. I'm in California, and this is one of the servers belonging to Reddit. It's probably safe to assume that this server is physically near me. Let's try another one. Now my pings are in excess of 200 milliseconds. That's pretty close to the human threshold for perceiving lag. Whatever's at this address will load noticeably slower for most people, and it's probably pretty far away. This machine happens to belong to the Chinese social network Weibo, and it's situated somewhere across the Pacific. I hope you enjoyed this. In future episodes we'll talk about what exactly is happening on that 200 millisecond round trip, how we managed to shoehorn names like google.com into the networking process, and how everyone on the internet seems to have exactly the same IP address for their router. In the meantime, I encourage you to play with ping. Check out its manual and try out all the different options. It's not like you can hurt anyone with it. Or can you? While poking around with my ping command, I noticed a few options. The first is -S. On my computer it means packet size, and keep in mind this might be different for you. When you ping a target, the message is a random sequence, about 60 characters long. Normally we can't set the exact message, but we can influence ping to specify how long the sequence should be. The other option is this -I flag. Normally pings wait 1 second between each ping, but we can drop that interval down to basically 0. When we combine these two, we can manage a little bit of mischief. Those round trip times I've been showing you, most of that time is spent in transit, but a tiny percentage of that number is the computer processing the message and building up a reply. A 60-character message takes microseconds. Now look at what happens when I bump that number as high as it'll go. We're going from 60 to 65,000 characters. When I do this, it adds a whopping 25 milliseconds to the ping time on my router. It takes a long time to copy a message that large. Okay, so we can slow the router down a little, and that's kind of fun, but so what? Well, remember when I said the target is obligated to respond to all pings? I meant all pings. It doesn't have the luxury of saying, I'm feeling a little tired, maybe not this one. It's got to respond to each and every echo request. So we shorten the ping interval, and then we open another window and do the same thing, and another, and another, and another. Eventually you can completely overwhelm the target with so many huge pings that it basically just shuts down. It's too busy replying to do much of anything, really. Of course, your computer is so busy sending the pings it can't do much of anything else either, so it's a bit of a Pyrrhic victory. This attack is called a ping flood, and if there was a book, it would be one of the oldest tricks in it. See? Networking isn't so boring after all. Anyway, if you like this video, then hit subscribe, and please join us next time for more antics on immature computer science.